Students, welcome to this session. In this session, I'm going to discuss you about the powers in superposition theorem, whether they are applicable or not. Okay. In the last video, we have discussed about the voltages and current calculations using superposition theorem. So now I'm going to discuss about power calculation. But before that, let us once again read the statement of superposition theorem. So superposition theorem state that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is used to solve the networks where two or more sources are present and connected. So here, if you observe, this theorem is only for this theorem, it is only for linear active bilateral network. Now, what do you mean by linear? Linear is nothing but an element when change in input will exactly gives you the change in output. That means output will change according to the change in input. Then that is known as your linear element. What is active? Active means it must have some source. So there should be some source present in the network, so that is known as your active source or active circuit. Now for the same problem, I am going to show you the power calculations. Okay. So in this problem, it was given that to find the current flowing through 8 ohm. So we have obtained by using different sources. That is, one is the voltage source and the other one is the current source. We have calculated the powers. We have calculated the voltages and currents according to the question asked. Now I am going to discuss how to calculate power. We know that power formula P is equals to either VI or I square R or V square by R. Okay. So as the superposition theorem is only valid for the linear elements, that means it should be a linear function. That means it should be directly proportional. But here if you observe from these equations, you can see that P is directly proportional to I square or P is directly proportional to the V square. So such type of systems where the power or the element is not exactly the linear, then superposition theorem is not valid. Okay. So let us check whether it will be valid for these powers or not. Okay. So first I am finding the power across 8 ohm resistor using 50 volt source. So power of 8 ohm resistor at 50 ohm source is given by current across 8 ohm resistor at 50 ohm source. This is square I square into 8 ohm because that is the resistor. So the value of current across the 8 ohm resistor due to 50 ohm source is 1.78 square into 8. So this value is 25.34 watts. So the units of power are watts. So this is the power in 8 ohm resistor due to 50 volt source. Now similarly find the power in 8 ohm with the other source, that was 5 amperes. So power in 8 ohm resistor due to 5 amp source is given by current in 8 ohm resistor due to 5 amps square into 8. So here what is the current flowing through that? It was minus 3.57 whole square into 8. So this value is nothing but 101.95 watts. Okay, so as in current, the summation of two currents was the total current flowing in that element. Now the addition of these two powers should give us the same value when total current is multiplied by the 8 ohm resistor. So just I am adding these two powers. Okay, so power in 8 ohm resistor due to both source is equals to 25.34 plus 101.95, whose value is nothing but 127.29 watts. Okay, so this value should be equal to the power if we multiply it with the both source currents. Okay, both currents. So what was the total current? Total current was minus 1.79 whole square into 8. So this value is equal to 25.63 watts. So here you can observe that the powers the powers due to the addition of two currents a whole square multiplied with the resistor is not equal to the power calculated individually. That means this theorem, superposition theorem, is not valid for powers as as not for powers as power is a non-linear element, Now why it is non-linear? It is non-linear because the power is directly proportional to either square of current or square of voltage. Okay,